Okay, so today we'll discuss again Kubernetes. So what is the meaning of Kubernetes? So Kubernetes is a container orchestration kind of tool. So what is the meaning of container orchestration? Like automatically we can create, scale up, scale down, or delete, or load balancing, self-healing kind of things. All those we are getting through the Kubernetes. With the containers, it's little challenging to manage thousands of containers manually. That is the reason we required a Kubernetes kind of thing on top of container runtime. Can you tell me what are the different container runtimes we have? So what are the different container runtimes we have? Okay, so we have the container
Docker.
D, CRIO, Docker engine, or we have like even Firecracker. Previously, Docker also is supported, but now directly Docker is not supporting. Okay, through the container D only that is supporting the container runtime. Okay, so then Kubernetes word came from Greek, like a pilot, governor, or helmsman who is going to contain, who is going to govern the ship. And what Google did is, Google for internal applications, they used to use Kubernetes, but now they made it open sourced. They made it open source. Okay. So then compared to Docker Swarm, like for the large scale applications, it's a proven solution and even cloud native kind of support is there. And for AI ML workloads, self-healing, load balancing is comes. Only the challenge is little complex compared to Docker Swarm. So whereas Docker Swarm is very easy to manage. Okay, even for the small environments also it is easy, and for dev and QA kind of things also. And my application is not going to scale up in the future. So that kind of workloads, better to go for Docker Swarm. Okay, so then mostly for our real-time applications we are using Kubernetes itself. Okay, and even the demand also day by day is increasing for the Kubernetes. And competitors are like what are the alternates in the market we have is, so we have Docker Swarm, then we have Nomad, Tanzu is there, Redshift. Okay, but managed services, even Tanzu also is VMware managed Kubernetes is called as Tanzu. And now we have here EKS, AKS, all those also we have. So these all comes under managed services from the cloud. Like AKS, EKS, GKE, or like OK is there from Oracle also we have. So everyone have their own advantages and disadvantages, and mostly the deployments of microservices also is going to managed services itself. Okay, so coming to the components, the Kubernetes architecture having a master and worker or master and slave kind of cluster architecture. So here we have the control plane and the data plane architecture we have. So we have the control plane and the data plane architecture we have. Okay, so then in the control plane architecture or master components, we have the API server, then we have scheduler, etcd, then controller we have, or Kube API server, etcd, Kube controller, then Kube scheduler, then cloud controller also we have. Okay, so then like what is the front end of the Kubernetes cluster for the like a kubectl or for third party tools is, what is the front end of that?
kubectl,
A
VM.
kubectl. No. Kubectl is the command line tool.
Okay.
Okay, API server is the front end. It's not only users need to use kubectl, they may use third-party tools also or APIs also, programmatically also. Like who is going to take the request is API server. API
Server.
server we have. Okay. So then in the Cube API server, okay, so what are the things we have is like it's going to provide the authentication, authorization. Say suppose if the user like both are using kubectl itself, but for one user we don't have more permissions. For one user we have more permissions on the cluster level. Okay, so then here we are going to manage. Okay, say like here we are going to manage authentications, authorizations, what are the permissions have been given. All those are managed by, like in the AWS also, whenever we use the AWS CLI, is going to use authentication IAM we have. In the Kubernetes, the same thing we have is like RBAC. What is the meaning of RBAC in the Kubernetes is role-based access control. So what is the meaning of RBAC? Role-based access control. Whenever the user is accessing the Kubernetes, like based on the user details, Kubernetes is going to like authenticate and authorate also. What is the meaning of RBAC here is role-based access control. So role-based access control we have. Okay, so then API server like is going to communicate even with the etcd also. And what is the meaning of etcd? Etcd is not a Kubernetes related product. That is a third party like NoSQL kind of database. And the Kubernetes also is using etcd itself. Okay. So then etcd is just like we have MongoDB, Redis. These are NoSQL kind of databases. etcd is also one of such database. Okay. So it's called as distributed key value
Yeah, list.
store kind of database. It's a NoSQL kind of key value store, NoSQL database, and all the meta information is going to store in the etcd, like node details, object details, secrets, config maps, events, leases. All these are going to use like in the etcd, and in the real time we'll have multiple etcd servers also. It would be distributed also. That means even one etcd goes down, it's a single point of crash. In order to avoid that one, we are going to keep in the multiple. And we have an algorithm is raft. Raft is one of the algorithm it is going to use. Even if you have the multiple etcd in the cluster, one master goes down, there would be an election to select the leader kind of thing also. There are some algorithms, but as of now, like if you go for managed service, EKS, AKS, all the control plane is managed by cloud provider itself. That means if you use EKS, all the API server, scheduler, etcd, their backups, all those are taken care by AWS itself. If I use AKS, Azure Kubernetes Service, those are managed by Azure. If I use GKE, those are managed by GKE itself. But if you are installing on premises, then we are responsible for those. Then we have like a controller manager, like we have specifying this is my expectations, this is the actual state I'm expecting, and like sorry, desired state I'm expecting. Whether that state is there or not is going to be verified by the actual state. Whether that state is there or not is going to be verified by the actual state is going to be verified. Okay, so that's we have the controller manager. We have the controller manager is going to manage those. Okay, so that's we are going to store those. Controller manager is going to verify that. Okay, so then like in the controller manager, we are going to control node controller, which will in the cluster, we may have some hundreds of nodes also, whether those nodes are working or not. Okay, so those all will manage. Replication controller, like I specified 10 parts, whether 10 parts are running or not. These called as replication controller, deployment controller, job or cron job controllers, endpoint controllers. These are the different type of controllers we have. There are some other third-party controllers also. By default, we are not getting those. Depends upon the requirement. We are going to create those controllers also. We are going to install those controllers also. We are going to install. Then, like if you are using any of the managed service in the cloud, okay, or even if you have on premises, we want to use some of the cloud services. I want to use cloud storage. I want to use cloud authentication like IAM kind of services. Load balancers I want to use. Okay, so then we need to use cloud controller manager. We need to use at that use case. We need to use the cloud controller manager. We are going to use. Okay, so it supports even on premises also, but if we are using managed service, for that also we are going to specify those. Okay. So can you repeat what are the control plane components we have? What are the control plane components we have?
API server, scheduler,
API server, yeah, scheduler,
etcd,
etcd,
Control.
controller.
ECDC.
container runtime.
No, container runtime not.
Uh,
Cloud controller manager. Container runtime is an agent service.
yes.
Okay, so even we required on the master also, but we don't tell on the master one.
Okay.
Okay, so then even on the scheduler, what is the role of the scheduler is on which node the parts need to run is going to be scheduled. On which node the parts need to run is going to be scheduled. Okay, so there how the scheduling works also we'll discuss. Then worker nodes. Previously for the worker nodes we called as minions, and we can call that as data plane. In the data plane, like mostly we have the kubelet. So what is the concept of kubelet is? So kubelet is the agent service. That agent should be run on each and every node and is going to communicate with the Kube API server, and it will make sure all the parts are running as per that. So it will take the instructions also from the API server, and according to that instructions is going to run, and it will report also the health of the node and what is the state of the parts. All that is going to be reports. Okay, and even in the backend in the node, we require a container runtime also, and based on the container runtime, it's going to communicate. Okay, so we have the different container runtimes. We have the container D, CRIO, gvisor, Kata, or Firecracker. Okay, so those all we have. Then kube proxy. So kube proxy is going to expose the parts like the traffic routing is going to be done using the kube proxy. That network service is the kube proxy we have. Okay, all that rules, all those also we are getting. On top of that, we have a container networking interface also. We require CNI also between the node to node communication, and it provides the IP address, which range of IPs is required, network policies, all those we are going to manage through CNI. Okay. All these are going to say, suppose we have the different CNIs. By default, we don't get the CNI. One CNI like a driver we need to choose. Can you tell some of the CNIs we have is Calico, Flannel, Weave. Okay. So we have the different uh, providers we have. So it depends upon our requirement. So we need to choose which type of CNI is required. Okay, so which type of CNI is required, we need to select. Okay, so we have the different CNIs we have. Okay, so then here, the important one is Calico, you can tell, or View, Flannel. Okay, so now if you come to AWS wise, if you are using EKS, then AWS VPC CNI. If you are using Azure, Azure CNI. If you are using GCP, GCP CNI also we have. Okay, so it depends upon our requirement. We need to choose which CNI we require. If we don't choose the CNI, the parts are not getting those IP addresses, and even node to master communication also is not going to happen. Okay, so those nodes would be in the not ready state. Said you tell in the on-premises we use Calico, but now we are using AWS VPC or Azure CNI or GCP CNI itself we are choosing. Okay, so then CSI driver, this is the driver. Say suppose I'm using EKS, but all my pod data, so normally in the Kubernetes we use, or in the Docker we use the volumes, right? But now I want to store the data in the EBS. By default, like EKS cluster can't use that data. So for that we required one CSI driver is required. So CSI driver is required for that. Now we are using EBS CSI driver we are using. If you are using Azure, Azure this normally EC2 to EC2 data is stored in. Normally that EC2 data is stored in the
EBS.
EBS.
itself. But now by default EKS can't use this. We required one more CSI driver is required. That means if you are using EKS and if you want to use EBS, then they are providing some drivers. Okay, and the part to yeah.
Means similar volumes we can
It's
use
just like a
CNI.
volume. It's a volume, but in the Kubernetes, it's little complex kind of thing. Okay, so the storage is not storing normally in the var lib volumes underscore data volume name and underscore data. It's storing right on the same mission, but that's not an enterprise use case. It need to be centralized and distributed. That's the reason we are using EBS volumes. Okay, but by default that communication permissions won't come. We need to set up, and one of the prerequisite is CSI drivers are required. CSI drivers are required. Okay. Then how the network part to part communication happens across the nodes, service discovery, network policies. These also will discuss. Then operators also will the highest level. Observability. So these all will discuss. Helm is a packager. Normally in the Ubuntu we use apt, right? apt, rm, dnf. These are the different packagers we have. On top of Kubernetes we are going to use. On top of this we are going to use Helm is the packager. Helm is the packager we are using. So again, if you communicate, like API server is the front end of the Kubernetes control plane and communicates directly with the etcd, will retrieve the actual details. If it is like a get response, that means I want to retrieve some details, then the display, say I want to get the details of nodes, parts, that will retrieve from the etcd and displays to the user. Okay, if it is if I want to perform some operations, say suppose I want to create or I want to deploy kind of thing or update, then even those instructions also it will take. Mostly whenever the user gives the instruction, it's going to authenticate, authorize, and retrieving the details, all those. Okay, so then through the API communication is happening. Then etcd is a key value store database and it distributed. Then we are going to get all that details of the object details, all the meta information is going to store in the key value kind of NoSQL database. And if I want to take the backup of the cluster also, we need to take the backup of the etcd itself. So we need to take the backup of etcd, we need to take it. Okay, internally that is going to use Raft protocol. Okay, so that's some algorithm is there. If any of the master goes down, how is going to send, and the backups also we need to take that. Okay, so we need to take a odd number of masters. Okay, and even if one goes down, we'll have another, like a cluster would be there. And scheduler, like, is going to decide on which nodes the pods need to run. Okay, so on which node the pods need to run. So there would be depends upon the node resources. There would be a lot of factors. Based on that, like, it's going to get the priority of the node, and the scoring would be there. Okay, so what are the least allocated resources, balance resource allocation, node affinity, image is there. So based on these all the factors is going to identify the node. Okay, even we can keep the control also on the nodes. Okay, so then the kube controller manager, it will control the node failures, heartbeat. Say if any of the node is down, then that's going to communicate. Replication controller will make sure like the right number of parts are running. Deployment controller will take care updating or rollbacks of that. Endpoints, for the every service to expose, we are getting a service endpoint, whether that is healthy or not. Those all service account and tokens, job and cron jobs also is going to schedule all these. Okay, so these would be based on the information it is collecting, is going to give the instructions to API server. API server will tell that to the scheduler, these things need to be performed. Okay, so then in the cloud base, if you want to use the resources like load balancers or IAM kind of integrations, then we want to use RBAC kind of storage. Then we are using a cloud controller manager. Okay. Then on the agent side, check we have the API server. It should be running on each and every node, and like it takes the instructions from the master to the API server, and those parts are running as per the expectation state or not. It's going to check it. Then kube proxy, like, is going to verify those network proxy and load balancing. Okay, so routes the traffic to the right pod. Okay, so that's going to route the traffic to the expose the traffic to the right pod. Okay, and even it is helpful for the API server to watch for service and endpoints. Okay, so then we have a container runtime. Okay, so we are managing from the Kubernetes wise at the pod level, but the backend to that, it need to manage those resources at the container runtime itself. Those need to be managed. Okay, so it's going to pull the images and creates, run, stops, delete the container. So suppose here I have a doubt, if my pod is deleted at the container level, then at the pod level also it's the same behavior it comes. Means even we need to have basic knowledge on the container level also, we need to troubleshoot those resources need to be troubleshooted. Okay, so those resources we need to troubleshoot. From that perspective also, we need to troubleshoot those. Okay, so then here, we'll discuss that if I type a command, how is going to happen in the backend also, we'll discuss. Then, like, here we have two command line tools. One is kubectl, second one is kubeadm. So kubectl is a command line tool, mostly the administrators or DevOps engineers, developers. Every day to communicate with the Kubernetes cluster, we are using kubectl. Is going to communicate with the API server, and the API server will communicate with the etcd, and it's going to retrieve those details, mostly to perform the operations, to deploy the applications, or viewing the results or resources, debugging, scaling we are using. Whereas kubeadm is if you want to initialize or bootstrap the cluster. Okay, so normally in the Docker Swarm, we use Docker Swarm init, Docker Swarm join tokens. That's the kubeadm is the bootstrap tool. So using the kubeadm init kubeadm join, we are going to perform those, and it's going to generate the tokens, certificates, all these is going to be handled. So that means for the first time in the managed services, we no need of kubeadm because that is inbuilt managed by AWS itself. But on premises, whenever we want to use the bootstrapping of the cluster, then we need to use kubeadm tool is need to be initialized. The kubeadm tool need to be initialized. Okay. So it's not required in the cloud. So can you tell me the difference between kubeadm and kubectl? kubeadm and kubectl, can you tell me the difference?
kubeadm is a bootstrap Kubernetes cluster.
To bootstrap, but in the managed services, we don't use much about kubeadm. We'll
Yeah.
use the
kubectl is a administrative command line and command line tool.
yeah, it's a command line tool.
Tool.
Okay. So normally we have the kubectl get pods. We'll discuss. So just like in the Docker, we have all the commands we go through, right? In the same way, but we don't use Docker commands mostly in the Kubernetes. But kubectl commands, everyone required good knowledge, and the most frequently used commands we required even in the job also. Mostly those we are using those commands. Okay, so kubectl is the client CLI for interacting with the clusters. kubeadm is tool to bootstrap and configure the clusters. And if you are using managed services like EKS, okay, so that's we are going to use like EKS also we have. So EKS CTL also we have. The tool also will discuss. So then it's in the AWS wise we have the EKS CTL tool. Okay. Okay, so then like here we need to discuss namespace. So what is the concept of the namespace is we have the cluster and that namespace we are going to partition that into Kubernetes cluster we are going to partition. Okay, so I'll tell one example. We have a Kubernetes, say suppose we have a floor, complete floor, we are partitioning it through we are partitioning through the rooms, we are constructing the walls, right? Or even some of them will have glass partition or aluminum partition. Like this here we have a cluster, but I want to logically differentiate that into virtual clusters. Then we are creating a namespace. The same cluster I want to use for multiple projects or multiple applications or multiple environments. Then we are going to use the namespace. Okay, so then we are going to use namespaces. Say, can you tell me what is the use case? Say, I have a team, one project only want to use the cluster, but I have three environments. I have a dev, QA, staging. Then production team is complaining, everyone are using like more resources. Dev and QA is using more resources on the cluster level. Then we are not getting more resources for production. At that moment we are going to use the
Names.
namespaces.
Names.
Means we can create the namespaces like dev, QA, staging, production, and for each namespace we can allocate the resource quotas. Okay, so now for the each room, say suppose even if you have a like builder floor, like again flat wise will have the space, right? Like maybe 1000 SFT, 2000 SFT. Each room also will have the measurement. That is like physically we are constructing, but namespaces are is a logical partitioning. Okay, so what is the advantage is whenever we have the multiple environments, multiple team, multiple projects. Okay, so that's we required like namespaces are required. What is the main advantage of namespace is we can allocate resources to the namespace. Okay, so I'll tell one use case that my cluster having like 4 nodes, each node having 4 virtual CPUs and 4 GB RAM. Okay, then total all we have 16 virtual CPUs, 16 GB RAM is available. 16 virtual CPUs and 16 GB RAM is available. For dev, I want to give only 2 GB, 2 virtual CPUs. For QA, I want to give same thing. Okay, so vCPUs I'll call virtual CPUs. Then for the staging, I want to give like maybe 4. Remaining I want to give for the production I want to give. If I don't give the namespaces, what is going to happen? If I don't give the namespaces, what is going to happen?
By default, it will do.
By default, dev will take more resources and the QA takes for production. We are not going to get. For production, we are not getting more resources, right? But here, that for the production, we have almost 8 CPUs. And 8 GB RAM, we got like that is reserved for that. So this is possible through
namespaces.
Namespaces itself. This is possible through the namespaces. If I don't have the namespaces, that is not possible. Okay, so that is not possible. Okay, so by creating only the namespaces, we don't get. But what we need to do is what we need to do. So we need to allocate the resource quotas. Okay, if we don't create any namespaces also, by default, we are getting 4 namespaces. By default, we are getting 4 namespaces. We are getting, okay, so one is default, second one is cube system, then cube public, cube node lease. So can you tell me what is your understanding of namespace? To virtually like partition the cluster, we are using the namespaces. To virtually we are partitioning those cluster. Okay, so that's cluster we are going to use. And by default, if you don't create also, we are getting the namespaces, default namespace, cube system, cube public, cube node lease. And if I don't use any of the namespace, okay, those are going to use in the default namespace. Default namespace. Okay, so we are going to use default namespace we are going to use. Okay, so then, but it's not recommended to use all in the default namespace. Your project or your environment specific itself create the namespaces, and even the permission level also that rollbacks or RBAC also we can give by using the RBAC rules we are going to define. Okay, so that's like RBAC rules we are going to define. Okay, so that means I don't want to give for the developers for QA environment or for staging environment. That RBAC level, we can define those roles also. That is also we are using namespaces. And namespace to namespace also, I can block the communication also. For that, I'll use network policies. And default, what is the difference between default and the cube system is like in the cube system, we are using internal Kubernetes level also. There would be a lot of resources. Those are going to use cube system. Okay, sir. So cube system will manage them. Okay, so cube system will manage those all the resources. That means internally for the master components or for like a API server, kube DNS, kube proxy, kubelet, metric server, all these also etcd also, these all running in the cube system. Means internal resources are running on cube system. Customer level, we are going to use a cube system. We are going to use cube public. Anyone can see, even unauthorized people also can get, but not recommended to use cube public. And heartbeat related, all these we are going to use like in the cube node list we are going to store. Okay, but we are creating our own cluster. So now here we have kubectl get namespaces will display. If you use the like kubectl get namespaces, what we are getting, all namespaces we are getting, but we want to create a separate namespace. If I don't use the dev namespace, what is going to happen is, say here, if I, what is the difference you need to tell? Kubectl get parts, if I type, it shows from the default namespace. Okay, but by using kubectl get parts -n, that dev is, if I use that hyphen and what is going to happen?
Create
When
namespace.
creating namespaces,
It's going to use the namespace it is going to use. That means if I use only kubectl get parts, it tries to retrieve only from the,
default namespace.
yeah, that is not a best practice. Okay, so a lot of people would be confusing also. We are not getting those details. Okay. Then if you want to delete a namespace, kubectl delete namespace, that dev. So this is very, very important. So by default, if I run kubectl get parts, what's happening? By default, if I use kubectl get parts, what is going to happen?
It's showing the
Hmm?
default
Uh,
namespace.
kubectl get parts, what's happening? It is showing from the default only. That means default
Default.
context is default, but I don't want to use. Always I don't want to type hyphen n that dev. Then I can set that like in the current context itself, I'm setting up dev n. If I set this command, then if I type kubectl get parts, it is running from the
Default.
dev itself. It
Namespace.
is running. It's running from the dev itself. It is
Dev.
running from the dev itself. Okay. Means you no need to give hyphen n. Say, can you tell me, this is very, very important command. Can you tell me what this command is doing? By default, the namespace is default namespace, but I want to change that one. Okay, then I'm keeping my namespace in the current context. Then I no need to use that namespace. That means it won't get from the default. It's going to retrieve from the,
Environment.
yeah, from that itself is going to work. You got it right? Config set type and context current equal to dev namespace, or I want to work with the prod. Okay, so my project is ITCM. I already created this namespace. That's I'm going to get that. Okay, so then By default, kubectl create namespace also is there, or we can use a YAML also we can create. Through the YAML also, we can create the namespace. Through the namespace also we can create. Okay, so what is this namespace? Once you give the YAML file, normally like kubectl apply -f, that YAML file name we need to specify. Most of the resources in the Kubernetes, we don't use kubectl command. We are going to create an YAML file. And what is the command we are creating here? Kubectl create -f.
Namespace
Yeah, whatever the name we have given for that file, that YAML file name we need to specify. Then what is the difference between create and apply?
First time you can create, use kubectl create. If in case modification anything is there, kubectl apply. That namespace, any modification is there, then we can use kubectl apply.
We are using for the first time. Apply if you want to modify. Okay, but we can directly use apply also. We don't need to use create itself. If it is the first time, it will create. Otherwise, it will apply those. Got it right? For most of the resources, for every resource, we are going to keep in the YAML format itself. Okay.
Okay, sir.
Then even the pod, all those also, and namespaces are logically, we are going to partition the cluster. Okay, and default namespaces, we have default, kube system, kube public, kube node list we have. And the set type and context, we are going to set that our namespace as the default namespace, we can set the context. And the namespaces can be created either through kubectl command or YAML. Okay, what is the best practice? Through the YAML itself, because in the DevOps, everything we need to keep as the file itself. And that's we are going to keep in GitHub kind of repo. Then pod. The pod is the smallest deployable unit in the Kubernetes. The pod is the smallest deployable unit in the Kubernetes, and we are going to create like a pod mostly will contain, say suppose, so if someone asks about the pod is smallest unit in the Kubernetes. That means on top of the pod itself, we have the next resources. Those are called as high-level objects or pod controllers. Okay, so that's we have deployment, stateful set.
Sir, container also smallest deployable unit.
No, that's not from the Kubernetes level, right? That is at the container runtime level.
Runtime, okay.
Okay, so I'll tell one example. So now we are using AWS. Okay, AWS wise. Okay, say we are creating an instance, but the backend in the VM, it is like in the GenSource or maybe in the Nitro, it's a VM only. But in AWS wise, the users are not directly hitting that VM. We are managing from instance. The Kubernetes level also, we are managing the pod, the backend, the container runtime will create the container. Okay, in the pod, we may have one container or multiple containers, we can specify.
Yes.
Got it right?
Yes, sir.
So we can specify either one container or multiple containers. We can specify those.
Okay.
Okay.
Okay, sir.
Okay. Then don't tell the pod is the lowest or smallest deployable unit. Okay, the better definition is pod is an encapsulation of container, okay, that network storage. So pod is an encapsulation of a container, that network storage as a single unit we are managing. So what is the meaning of encapsule is normally in the medical also will have the capsules, right? Medical capsule, it's having all the medicine, it's going to capsule into that. Now here encapsulation is in the one bundle of unit, we are keeping one or more containers, their shared network, their shared storage. We are grouping that into the pod, and which is the smallest deployable unit we have. The pod is the smallest deployable unit we have. Okay. But we don't directly deal with the pods. Even the pod level, higher level of objects or pod controllers we have. For that we have deployment. We have stateful sets, replica sets. What are those also we'll discuss. Okay. So we have the deployment, or directly in the real time, we don't deal with the pods. Okay. So we will deal with the deployments or stateful sets or replica sets. Normally in the Kubernetes, sorry, in the Docker, those are called as services. We don't deal with the replicas, we'll deal with the services only. Okay.
So once again, tell me deployment stateful set.
Yeah, these will discuss.
Then
These will discuss. Yeah. First parts we are discussing. Next session we'll discuss those deployments, all those. Okay. So now I'll tell. Say in the deployment, if I give 10 replicas, 10 parts are getting created. But I no need to specify 10 times those parts. One template file itself, I'm creating as a deployment, but it is creating 10 parts are getting created, but I'm not dealing with 10 parts or 100 parts. I'm creating only one deployment itself. That means for one microservice in the Kubernetes, either we'll use deployment or stateful set or replica set. Okay, there are the slight differences between them that we'll discuss. Okay, then a pod can have a single container or multiple containers. Both it can contain. Mostly we are using single container pod. Okay, but it can contain even multiple containers also, it can go. There are some special requirements why we'll go for multiple containers also.
Same network.
Yes, if you want to share them. Otherwise, in the microservices is always distribute them. Don't keep in the single one. Okay. So we can have a multiple containers also, but that's not recommended. Okay, so there are some special use cases, we'll discuss that. And the pod is going to share the networking storage also if you have the multiple containers. And mostly the pod goes to pending state, running, failed, succeeded. That pod lifecycle also we'll discuss. And the pods are not permanent. Okay, so those would be recreating. Okay. And mostly we'll use one pod is one container, or we can have a multiple containers. Both the containers want to share like multiple containers, then we are using. Even the pods also will create through the YAML itself. These all the YAMLs will discuss. One YAML or two YAML scripts for all the resources. Everything we are managing through the YAML code itself, and those YAML also will discuss. Okay, then even that pod YAML we are keeping in that YAML code, and from that we are going to create kubectl apply -f that pod YAML we are going to create. Okay, then this is very, very important. What are the status that the pod can go in the lifecycle events? The pod will goes to pending state, running state, success, fail, unknown. Say here, even in the failed state also, maybe we have a container loopback, pullback issues. So these all like we need to troubleshoot in the real time, because we don't have only one or two parts running for the high scalable application. Some thousands of parts are running. Some part of like maybe 1%, 2% of the parts also is a huge number, and those may be going into any of these issues. Then we are getting an alert also from the monitoring mission, and we need to troubleshoot why those issues are coming. Pod is the smallest deployable unit, which is going to encapsulate one or more containers, that storage and networking. Okay, so these all, like on top of the pod controllers, we have the different resources. Okay, so those are the pod controller objects like deployment, stateful sets, replica sets. Then we have very, very important services we have. So then we have a headless service. Then PV persistent volume climb, storage classes, then ingress. Then very, very important config map, secrets. So we need to discuss all these resources. Okay, so mostly in the next 2 to 3 classes, we'll discuss all these. What is the purpose of, say, we have around 30 to 40 objects in the Kubernetes. Those all the objects will have the YAML file also. Everyone need to know that YAML structure also. So it depends upon our requirement. All these finally we can create using a single packager itself. That is the Helm. Okay, so we need to understand that Helm charts also. These all we'll discuss in the next session. I'll share one more video also, go through that video also for today itself. Okay.
Okay, sir.